Good morning.
Morning.
Good morning.
Morning, everyone.
How is everyone?
I think
Good,
this
good.
is on, right? Are you guys out vacationing or?
I don't know. Is anyone taking a vacation?
I am going in summers to India.
Okay.
Yeah, me. So let's bring this to a good stopping point so we can resume. So, anyway, okay.
All right. Yeah, just give me a second here. I'm also pulling up Kindle. I'm doing the share screen thing. Okay, so I think last time we left off here. And we were talking really just about, again, the whole documents versus relational databases. And then we sort of got into query languages. So I want to just take a look really quickly here.
Yeah, basically the schema flexibility is harder to achieve with relational databases. So that's a big selling point for the NoSQL ones. Yeah.
Yeah, and then we had some sample code to kind of go through. That's what we looked at last time, like document JavaScript type code versus doing the same kind of code in SQL where you're altering a table. Which one was easier? But at the end, it kind of comes down to just what your use case might be, and if you're doing something with multiple joins, and a lot of different relationships, then you might want to use SQL or even graphs. So that's kind of like, I think where we left off is just essentially like in this area.
What do you use, Vijay, at work? Which DB do you use?
We use both. I think we've used, I've personally used documents for simple things like on the app side. But then we also have like full on API calls that are like backed by Oracle SQL.
Wow.
And my other job too, we used a ton of Oracle SQL. It was like where we kept a whole bunch of client data. So yeah,
So whenever you had to add a column, you had to kind of plan for it, take a downtime and do it.
Yeah, that's correct.
Okay. Okay.
But just to be transparent, like I wasn't doing all of that. I was kind of involved in some of it, but I wasn't working that much as a backend engineer. I was just kind of like working with back engineers, if that makes sense.
Yeah.
Okay. So this is an area I still also need to kind of like improve in some ways, which is why like I'm reading about it. Yeah, and it's having me kind of go back and look through everything again. So these are some tabs here that I've been kind of looking at and just getting familiar with Java once more and SQL. So, okay, so we are at this point in the chapter, I think, and we're talking about query languages. And so like the thing that I kind of started to do is make some notes here. And it says that SQL is very declarative, right? Whereas Codicil, more kind of like graphs or like documents, they're kind of using imperative code. And so this part of the chapter talks a little bit about the difference between imperative versus declarative, but I wanted to just kind of open it up to you all. Have you heard this term before?
Yeah. Declarative means it's telling like what you want out of it rather than saying how you want. Imperative is specifying the every details, like an example given below. We know exactly like I is equal to 0, we write a loop, and this is how things happen. This is an imperative code. But in relational algebra, we just say select my column from a given table, and internally how it translates this to is up to the database or the middleware, whatever it is in.
Yeah.
So yeah, that's the main difference between imperative and declarative.
Yeah, correct. And I'm actually going to make this full screen so anybody who watches this will be able to see the whole thing. Correct. I mean, like when you write in an imperative way, you're writing really more like step by step, like saying, okay, do this first, then do this, then do this, then do this, go to this particular piece of the, application, then, go to this number, go to this column, then, change the record from this to this. You're just kind of like being very, very specific. And then imperative is kind of like just saying, this is what I need. Like this is, I mean, declarative is you're basically saying, this is what I need, like from, this program. So the declarative way can be a little bit easier to work with because, essentially like it just has to achieve the goal, but it's not, you haven't kind of determined how that program should be written. So that was kind of like the note I highlighted here. It's up to the database's system query optimizer to decide like which indexes and which join methods to use and which order to execute various parts of the query. And you don't have to worry about all that. So that makes this a little bit easier for people building the declarative language. So
it's kind of an out-of-box solution. So if you don't care too much about optimizing yourself, then basically SQL does the optimization for you. You just tell it what you need. But the imperative, basically, because there is no structure, we will have to take over the control and basically handle whatever performance or whatever that we need to optimize for whatever needs that we have in our app.
Correct. Yeah. And that's really kind of like the thing nowadays, like a lot of stuff is becoming, a lot of developer communities are trying to embrace more declarative style because, then it's kind of easier to work with for the user, as well as it's easy for people to, manage on the back end or like of the, handling of the code. So I don't know if you follow like Swift, but there was like this big, jump from like Apple's Swift language to Swift UI, and it was supposed to make a lot of like Swift development easier because it became a little bit more declarative. React is a little bit like that too. It's a declarative language in some ways because you're kind of just saying, this is what I want, like in terms of like a component, and then you just kind of put components everywhere and then let React build out the HTML. So that was kind of like a nice thing that came out from that community. And you can contrast that to something like jQuery, which is, or even vanilla JavaScript, which is very imperative, right? You're really, when you're using JavaScript and the DOM, you're really like controlling exactly every part of like what you want JavaScript to do with the DOM. So I think more of the community is starting to move towards declarative. So I made another highlight here that imperative is basically hard to parallelize across multiple cores and multiple machines because it requires specific instructions that must be performed in a particular order. So this isn't something that like I'm very good at, but like I've started to read in a lot because I hear about it sometimes. As coming up is important in like interviews and stuff, but it's this subject of concurrency, right? Like nowadays, like, we don't have faster CPUs. We have more CPUs, like more cores. So basically that is kind of like something to consider too, like when you're writing code, you definitely don't want it to like interrupt with something else that's running at the same time.
So the way we handle, so like because we use the NoSQL thing, right? So our code is mostly imperative, like what according to the definition here. So in order to parallelize, we take advantage of Java streams, right? Java has this the app basically has support for this parallel execution in terms of streams, right? So we handle any data, data handling using that, and that kind of gives us a decent performance.
Correct. Good stuff. Anyone else want to add to this conversation? Just take a minute here. Is anyone studying concurrency?
I started looking into it, one of the machine learning platforms. Ray is a popular machine learning open source platform. And last week we had to implement something. I looked into how concurrency was implemented in Ray and what it really means, especially for Python. There is nothing truly concurrent because of global interpreter lock. Only one Python interpreter can run at any time. So I started digging into it, but not to a great detail.
Okay. We can always revisit this topic later too. There was a book that I was recommended, and I'll try to find it afterwards. But it was something about like Go language and concurrency. I think like Go language was built specifically for concurrency issues. So that was kind of like something I wanted to look into. So with this section, essentially, like, again, it's really just about, making sure that, you know, like the difference between like imperative and declarative language. And so basically, here again, they kind of give you some more examples, which was pretty good. If the database wants to reclaim unused disk space behind the scenes or move records around, change the order in which animals appear, an imperative code may not work, right? So if that's kind of like your goal, if you want to be able to like, have some ability to do optimizations behind the scenes for any type of code, then you probably don't want an imperative code style. And you might get that more with a document database than you do with a relational database. And that's something that's.
I don't understand what he means by declarative languages have a better chance of getting faster in parallel execution. I mean, the application is not doing any work here, right? It's basically the query optimizer which is doing the job for you. So where is this parallel execution taken advantage of?
So in my mind, I think that the parallel execution, right, again, going back to concurrency, right, like, so I guess, and I don't have a lot of insight into the subject, so I'd have to, lean on somebody else. Maybe we can get some discussion from the group as well. But just at a simple level, it's, the whole idea is that you're basically, you've got multiple threads going on, and some of these threads may have, like, if you're not writing the program correctly, or like whoever's doing the optimizer is not doing it correctly, if those programs or those threads are not synchronized in any kind of way, then what's going to happen is, like, sometimes, like, one execution thread is going to write to the database, stop like midway because another thread takes in priority depending on like how the kernel is running, and then that may start writing to the database as well. And so, like, you may have like issues where you have just the wrong thing being written to the DB. And again, that's why all these procedures like ACID and all this stuff exist, because you don't want, like two queries running the whole thing at the two queries running competing order or having race conditions between queries. So that's kind of like what it's about. So I open like this up though for anybody else who wants to kind of like contribute to this. Sometimes we have I think Srini, who has a lot of knowledge on this. He could probably give some insight.
Yeah.
Yeah, so this next section here, declarative queries on the web. I thought this was really cool because it's talking a little bit about like CSS, something that, you know, is pretty straightforward, pretty simple. So like here you have, you know, an unordered list, and basically, you know, you have a list of sharks and then whales, and then using select CSS, you know, in a declarative way, right? CSS is also kind of a declarative language. You can just basically say, hey, for any, you know, list item that I've put a selected class on, any paragraph tag inside there should have a background color of blue. And so that's gonna basically, again, this is kind of like declarative saying this is the end goal, but you don't really care about the implementation details of how the optimizer gets there. Essentially though, like CSS and the engine in the browser is going to find, you know, all the paragraph tags under the selected class and color them blue. Any, you know, any list element that doesn't have the selected class is not going to get that blue coloring. Then he also talks a little bit about XSL, which I have never used. So I'm wondering if anybody here has used that, but you can achieve the same result here. Whereas in JavaScript, which is again imperative, doing the same thing has like way more lines of code, and you know, it's possible to break something if you're not sure what you're doing, right? So this is just a better API in general, like, and it comes back down, like, again, like to the engineering part, the system design. Like when you're building something, maybe if your intent is for other people to use it, you may want to make it as simple as possible, not complicated. Anyone want to add to this?
No, I think it all goes back to the original point they were saying, right? So basically, if you have a lot of structure to your data, like in this, you have to write so many loops, because for each structure you have to write a loop, right? Like there's a sub element inside a parent element, and the sub. So basically, for each element you have a for loop. So that's why it looks so messy. So if you have such structured, like, you know, data, then yeah, document DB is like basically the NoSQL is in the right solve, and yeah, basically you better stick with the SQL way of doing things.
Correct. Anybody else? Okay, so basically, I think we kind of hammered this point, but I'll just kind of read out some of the highlights here as well. He says that the code's awful. It's much harder to understand than the CSS for, and I think this is true, right? Like for a lot of people learning JavaScript for the first time, there is a huge learning curve, especially in the sense that you have to learn all of the different methods on, you know, different JavaScript objects, and you have to know about what JavaScript objects are available, and then, you know, which ones are available from the DOM that you can manipulate. So it's a huge barrier to entry, where CSS feels a lot simpler because it's not really about, like, again, writing and memorizing objects, memorizing different points of the DOM. It's just writing out like specific things that you want to achieve, and then having the web browser do, you know, the optimization for you. So I just kind of wrote out here, like, when we use CSS, the browser automatically detects when the li is selected, the list element with the selected tag or selected class basically no longer applies, and removes the blue background as soon as the selected class is removed. Whereas in JavaScript, if you want to take advantage of a new API, such as document get elements by class name selected, or even document evaluate, you have to rewrite the code. And that's like another thing too, like at least with CSS and declarative, you don't have as much rewrites, because it's not so much about like what needs to get done step by step, but just kind of like the overall goal. Whereas here, if you go back to this code and you look through it, and it's trying to get all the list elements and then go through each one and then try to find the one that has a class name. If you want to, change this code, you actually have to rewrite it. So that's like another thing to consider, is that when you write in an imperative style, you end up, having to rewrite it often. So that's something, again, to like from like a planning phase. If you're thinking about something for business, you might want to go with something that doesn't involve multiple rewrites down the line. That goes to that idea of maintainability.
Yep.
Is this also towards portability, right? Like different platforms may need different optimizers or different way of doing things. So not exposing those details to the end user and having them have only declarative style of specifying what they need will shield them from various platform stuff.
Yeah. And you can kind of see like how this makes sense too in real life, even if you forget about CSS and all this other stuff, right? Like a lot of people like the iPhone, right? Or Apple's products because they are simpler to use. They don't have to, like, Apple never really makes the user have to like think about like, implementation details. They can kind of just work with, their products, their iPhone, and kind of like swipe and then, see something happen, right? You learn like some basic techniques, and then basically you're able to kind of, do what you need to do. But like, again, all the implementation is hidden from you. So it's just kind of like a paradigm. I think that there was a good article about it where somebody was talking about how like a Stanford professor kind of came up with this idea that everything should be a black box. Like everything, the user should never really know like what is inside like this black box. They should just only be able to use it. And then like when it interfaces with another, box, it's sort of seamless. So if I find that paper again, I'll share it on here too. It was a pretty interesting article, but I think that's something that Apple kind of subscribed to in terms of its methodology. All right, so I think basically we're on this section now. I think we got a good idea of like declarative versus imperative. And again, like key points is just like it's easier to look at, and then it's easier for compatibility, and you don't have as much rewrites. We have Mapreduce, which is kind of like the next section. This was popularized by Google. I think some of you are using Mapreduce. Is that correct?
Yeah, we use it for feature engineering, like when we have to parallelly detect a lot of features and do some common operations.
Okay. So this part of the chapter might have been interesting for you, right? Just kind of like a review session.
Yeah.
Are you using Mapreduce, mainly like with your own thing? Do you use like Hadoop, or do you use?
No, we use Mapreduce on top of our database, on top of our data, which is in Cassandra. Yeah, we don't use Hadoop or, yeah.
Okay, on top of Cassandra, okay. All right, maybe you could explain to us like what Mapreduce is, just at a high level.
So I'm going to start with a dumb example, which I started doing it in grad school long ago. So let's say you want to count the number of words, unique words in a book, and the number of occurrences of those unique words, right? So this is if you want to do it serially, you have to read line by line, and you have to keep track of these unique words and also a counter for these unique words. So serially, you can imagine, for example, here, let's look into the paragraph. Mapreduce is a programming language for all these things. So there are 3 sentences or 2 sentences here, and this will happen sequentially. You read every sentence and keep track of unique words, and then you increment the count of these unique words. In Mapreduce, what you can simply do is you can parallelize this task. For example, each sentence can be considered as a concurrent operation here. So in each sentence, you can, initially the map is like input is each sentence and the output is the key value pairs for each of these sentence. So there are two map jobs here. One is for the first sentence and one is for the second sentence. And you can get the unique words and their counts from these maps jobs. Then what the reduce does it combines these output from these maps and does a summation of all these things, that also in parallel. During reduce, let's say, is there any other word there? Performing read. Let's say machine is a common word in both the first sentence and the second sentence. In what happens during reduce is all the machine's key value pair will go to the same reduce job. So you can count all the machines or accumulate the results. So in that way, we can parallelize counting of individual words using how you set up these map and reduce job. Both map and reduce are both parallel tasks, and how you set up is in the driver code. You can say how map works and how reduce works. Reduce works on the output of map and does some accumulation or filtering or processing of all the map tasks. From the database point of view, map reads from its common database and writes the result again to some database, and reduce again reads from the database and writes the result to database. So that is a database call between map and reduce.
Okay, so basically the first database call is just doing the map, and then the second database call is doing the reduce. Okay.
Yeah.
All right.
How do you partition, like, so it is basically Mapreduce is like a library, is like a framework that basically gives you this hooks where you can say how to partition the data that you want to parallelize. And the reduce gives you hooks where you define how to aggregate the results, right? Is that what it is?
Yeah.
So it's basically it's not an engine, it's basically a library, and it runs in your application code.
Yeah, you need a driver. Yeah.
Mm-hmm. Okay.
So I just
from a quick question. So between map and reduce, what are the steps involved? There is some filtering that happens. Or
not filtering, it is writing to a database and reading from the database. Map and reduce are independent steps. There are two steps in a parallel processing. Map is a parallel processing and reduce is a parallel processing, and they read from the database. Reduce is more like a aggregation or filtering on top of the outputs of map.
So once map is done executing its step, it writes to a database?
Yeah, it writes to a disk. Yeah.
Disk.
Or a disk or a database. Yeah.
How does how are faults handled? Like, let's say something, some map job failed midway. Is there some state information that is persisted, or like you have to start the job all over again or something like that, and the results are discarded and you have to start all over?
So it depends on how the Mapreduce is integrated in your platform. So for us, we have written a job on top of the map and reduce task. So we track the status and we kind of know where it failed, and we have to restart. We have multiple ways of restart, either restart initially from stage 0 or restart from where it stopped, whether you want your operation to be idempotent or it's a state or a stateless. There are multiple variants. I don't know how it is used generally, like in Hadoop, because we use Mapreduce independent of Hadoop framework.
Interesting. Okay.
All right. So here he kind of says that Mapreduce is not declarative nor a fully imperative query API. It's between, and the logic of the query is expressed with snippets of code. It's based on the map and reduce functions that also exist in many functional programming languages. So this is like a common pattern that you'll see too, like in JavaScript. If you use React, you'll map over, maybe like, a list of, items in an array, and then you'll have to convert them into components. So that's the map part. And then later on, you might reduce them down into like one component or something. So you'll see that often too, like in JavaScript, map and reduce. And there are other uses as well, like as far as like mapping and reducing. And then filtering is also pretty common too. So just pointing that out. So some people who may not know what that is, they probably do. But Mapreduce is more common for, like, I think data, like that's the term you'll hear often, like for big data. So then he just kind of talks about being a marine biologist, and then you're adding observation records to your database every time you see animals in the ocean. You want to generate a report saying how many sharks you've sighted per month. In PostgreSQL, you have a query like this, select, the date, truncate it by month, from observation month, and then sub, all the total animals from observations where family is equal to sharks, and then group by observation month. So this is like how you can get all the sharks based by month. In MongoDB, this is kind of how you would do it. Rather than doing this select statement and the group, you could do a map and reduce, right? So you say, get the full year, get the month, and then, basically, I think map first runs, right? That's kind of how this works. They do Mapreduce as a function. So this function runs first, and then after that, this function runs next on whatever the result of map is. So, we get all the animals, and then for each value, we sum, or each key in this object, I guess, you sum all the values, and then you get a monthly shark report. So I'd probably have to dig a little bit more to kind of see about what this is exactly doing, but I guess they've kind of spelled it out here.
One point is reduce is always grouped by the key.
Right here,
if there are 10,000 new keys, and the reduce potentially can have 10,000 invocations or parallel concurrent processes running.
Yeah, you're pushing it all together into one thing, right? Reducing it all into one particular item.
Yeah.
No, what was that? So is that a gotcha there? So reduce, I understand what reduce is doing. Basically, it's grouping by key. Is and it is parallelly fetching those the keys across. I don't know how this is persisted. So basically, it has to be its own schema, right? How is this map result persisted? Do you define the schema for that, or is it handled by the framework somehow?
It is always a key value pair. So you have to persist this key value pair. Basically, if there are 100 keys, you partition and say, okay, my key X goes to partition P1. Key Y goes to partition P2. So this is how you persist in a key value. So it's just a key value persistence.
Yeah. So what was the point you were making? About the keys getting parallelly looked up.
Yeah, so when during reduce, if each reduce will pick some partition, and every partition will have one or more keys. So it will go and read from that partition and execute the reduce operation.
So basically, this framework handles the concurrency issues. Basically, the same key is getting updated by multiple map jobs, I guess, right, when it is running. So
yeah, they'll all be like independent entries. It won't be like the accumulation happens later, right? Let's say there are five map jobs, each will emit 5 key value pairs or something, right? Or and each can contain the same key, and it will all be persisted. Like consider it as like a append only data structure where it gets persisted. It won't overwrite.
No, got it. Okay, yeah. So key is not a unique thing. It's basically
many map jobs can produce the same key.
Yeah.
Got it. So the map function here is pretty much producing the key consisting of the year and the month, right? And then the value of the animal in that observation, right? So from this observation record, we're getting the year, right? And then the animals. And then we're reducing based on number of times we see the animal, like with the key, or I guess. And then finally, we're saying we want the sharks, right? Is that kind of like what your take is too?
Yeah, that's correct.
Okay.
Yeah.
All right.
Question. So when the map job is producing the same keys, say for instance, are those same keys going to the same partition for the reduce job?
They are going to the same partition. Every key is going to the, same key goes to the same partition. Yeah.
So map has its own partition and reduce has its own partition.
Map has its own partition. So during reduce, there is a bit of a over the network call if the partition for that reduce or whatever reduce needs to work on is not present in its partition. So it has to go and fetch from a different partition in order to do a reduce job.
Okay, got it.
So this actually comes with it's a DB feature, is it? Like
Yeah.
So I don't think DynamoDB has. Maybe it is. I don't know. We don't use it. So there are some. This is kind of offered out of the box for some NoSQL or maybe SQL also. Is that right?
It's not a DB feature exactly. It's just a parallel processing paradigm. And how you use it with the DB, you can use the same thing with the maybe SQL, but you have to write all the stuff happening between Mapreduce and how it interacts with the SQL.
Oh, but here he says MongoDB's Mapreduce feature. I was thinking it's something that.
Okay, yeah, it's maybe probably very unique to MongoDB, but Mapreduce is just a programming paradigm.
Yeah.
Parallel process. Yeah.
You can just install the library and kind of do it. Okay.
Yeah. Yeah.
Okay.
All right. So this next section here, let's see here. He's got the observation collection contains 2 documents. So here is the first, object basically with sharks. And then this has the number of animals seen. So Carcharodon carcharias, and then Carcharodon or Carcharias taurus. So it's a type of shark, another type of shark. And this would be like number 4. So this map function would be called once for each document, resulting in emit 1995, 12.3, and 1995, 12.4. Then the reduce function would be called with 1995, 12, 3 and 4 returning 7. So the total from this map in the reduce function would be 7. So I made a highlight here that map and reduce are restricted in what they're allowed to do. They have to be pure functions, which I guess like a pure function always just takes like one input and then it returns one output. Like you can't like do side effects, like perform additional database queries or, massage the data or anything else like that. It's always got to be like the same input output experience in a pure function. And because of that, then the database can run the functions anywhere in any order and rerun them on failure. So does anybody here have any experience with using like pure functions or writing in a functional paradigm? Does anybody like that?
I think Java has some functional programming. We use a lot of functional programming for data manipulation and machine learning. There is one more language we use predominantly, I forget. It is a completely Scala. Scala is also a functional programming language. We use a lot of Scala too. For us, the main advantage of using a functional programming language is parallelization, because they are pure functions and they don't have side effects. You can parallelize these functions easily compared to other imperative programming languages or like normal way of writing for loops.
That makes a lot of sense, actually. And what does Scala like mean? I know it's like, do you know like what the original name, or I mean, I guess like how it was made, like how they named the language?
I don't know how it is named in. It is completely a functional programming language, and they have these reduce, fold, and the normal. There is a good course in Coursera. I took it a while ago from a functional programming paradigm in Scala. It's from Ecole University.
Eco University?
Yeah, Ecole University's functional programming course in Coursera. That's a very good course for introduction.
How do you spell it?
ECOLE.
And then you said it was.
You can say functional programming, Coursera.
So Scala was invented in Switzerland by a professor for a need for embedding FSD into Java. Java didn't have a functional programming paradigm, at least till when Java 8 came, you had Lambda, all those features that
that Java has.
Ramya, yeah, sorry.
Yeah.
I was like, all those features, I just like freeze for a minute. All those features Ramya was mentioning. So Java didn't have the functional programming capability. Like if you can think of in Python, you always had Lambda capabilities, being able to stream, parallelize a particular data set. You can split and process them concurrently. All those features as such was possible in Java, but like you had to go to threading and all those things, right? You had to completely go down and break it yourself and manage it.
Mm-hmm.
So it didn't have FSD capabilities till 8. So Java, Scala was invented to be better Java, or you can even say Java on steroid, right? It had the functional language capability, and then it had a different mechanism of how, and underneath Scala still runs on JVM, right? The same principles how Java does, like, you know, after compilation, it breaks it down into bytecode, and bytecode gets executed at JVM level. Scala does the same thing, but Scala has, like, you know, a compiler which supports some of these capabilities. But the most important thing that Scala provides is immutability concept. If you go back to Java, we have capability to define a particular variable. And then again, although like strings are all immutable, you can go and like rewrite a variable's value and stuff like that. So it caused immense amount of problems. Over time, if you see in the code base, it's a lot of bugs and stuff. So Scala provides capability to build immutable code. In the sense you can define pretty much like a variable which is a constant forever, right? You have capabilities to, so those kinds of functional FSD capabilities were needed, and Java didn't have. JCP spec didn't allow it to have for whatever reason. So Scala was just an experimental project in a university in Switzerland. The professor did, I think it was REPL based, some kind of a thing. I look up which university, and then he did that, right? Once it came into mainstream, it so happened that the main adoption happened when they did Apache Spark in California, Berkeley, right? So they chose Scala. Actually, even LinkedIn's Kafka is built on Scala. So if you want high throughput, but still the same capabilities, ecosystem of Java, high throughput and immutability concepts, Scala shines really well. And there are tons of like high performance projects which are built on Scala.
Very cool. Yeah. And I guess like for what I was also saying too, like at the beginning, I think simply put, the reason the name came to was because it signifies scaling, right? Scale and then language. So maybe that might have been why they named it that way, scale language, grow with the demand of the users. But yeah, excellent discussion. I love the discussion too about the history about Scala and how like it was used and how it works with Java, the JVM. And then we have this course that
I
Ramya
pasted the
talked
link in
about.
the chat.
Mhm.
Yeah.
Mm-hmm. So cool. I'll definitely check this out too. It looks like it's free. So that's good.
Yeah, it's open source. Yeah, it's open source. And so the verbosity of Java, let's say if you write a business logic, which is like 100 lines, Scala can get it done more concise, maybe in 10 lines.
Mm-hmm.
So there are also Scala solves because it has a lot of FSD paradigms, streaming, breaking chains, and then like pretty much like Mapreduce, but more at a streaming level and breaking data structures, processing it, filtering it, all those capabilities Python by default had for a long time, right? So.
Mm-hmm, mm-hmm. Nice. All right. So So I think we've got a good handle on what Scala is at this point. And then going back to the Mapreduce and the examples that we saw here.
So before we
Sure.
move on, I was just contemplating learning some other language other than just Java, right? So, Ramya mentioned that Python can never be truly parallel. Python execution can never be truly parallelized, but at the same time, it is completely functional. It follows a functional paradigm, right? Is that
No, Python is not completely functional. It has Lambda functions which support functional programming. So Python is like Java also. Like it's not statically typed, but it supports functional programming like Java 9 does.
right? Okay. But then at the same time, so when is a good like before we start a project, we always contemplate which language is the right right one to take up, right? So when you have a need for such parallelize, basically, let's say you need to do some Mapreduce kind of an operation, given that Java does not really have this, I mean, it has some support for functional programming right now, but what is the go-to language that basically optimizes for the use case?
And for me, we looked at machine learning, right? I'm in machine learning platform and infrastructure. For us, all the machine learning related libraries are in Python. So the language which the data scientists use to express what they want is in Python. And how do we execute whatever they express is up to us. So sometimes we use Scala for some jobs, and we use Java for some of the jobs, and we do use Java's functional programming. So yeah, depends on the domain. How do you, for us, machine learning, Python was a no-brainer to pick for all the front-end coding.
So like Ramya said, machine learning and data science, right? The immense amount of tool that's available in Python, you just can't get away with it, right? It's probably better. Otherwise, if you choose some other language, you will reinvent. Even Java, you will reinvent a lot of things, right? Executing them is a different thing, right? Because it's still gonna get executed in Python language. But going back to your question, it depends on a lot of factors that drives this, right? Let's say if you're building a distributed system, nothing is gonna shine as fast and better like C. Everybody knows the truth. But C is hard, right? You have to do all the management. That's why Java was there. Now the new C is Golang. It is relatively simple. Still gives the power to do at a system level. So it depends on like if you want database, file storage, processing, all those things at an OS kernel level, then you will choose something more closer to the system programming where you have capabilities to do things like that. Maybe C, Golang, or Rust, right? Really, because of the performance and throughput that you expect. But if you want to abstract and like, make it a little bit easier for others and where you have more contribution, then you'll go general purpose like Java or maybe even .NET or whatever, right? So it all depends on what you're going to build. And the new thing off late is like, comparable to Golang is Rust, which is also a system programming language, but like highly memory and type safe from a security perspective. So a lot of options. It's not easy, right? To pick which one. It depends, like how Ramya mentioned, the team. You have to take care of the team. How many people are contributing? Do they have to upskill? A lot of factors come in, right?
I know there is, there is server-side JavaScript code. JavaScript is also completely functional, right? Are there any weirdos who write all this in JavaScript?
There are a few people who do write things in JavaScript, right? Like server APIs and stuff like in Node.js and when mostly full stack developers, right? Who know only JavaScript and Node.js, they write everything like Express APIs and stuff. They are good for a limited number of users and limited performance, right? If you want to go concurrency high, more performance and stuff, you definitely need to move away from JavaScript for sure.
Yeah, for sure. Yeah.
Because it doesn't give you capabilities to tune things, a lot of things, right? It's even for that matter, even Python does great, right? Like if you build an API on top of Python, yeah, sure, it does great. But high concurrency, maybe at some point you will some way migrate it away from there.
Actually, this was something we kind of started with during this section here, was like talking a little bit about concurrency. So do you have anything to add on that, Karthik? You know, like the discussion, like, do you have experience doing concurrency? It seems like you do.
Yeah, I mean, there are a few transactions where concurrency, see, it depends on different use cases, right? I'm pretty sure Amulya would, concurrency is one of the big things for her in Chime, right? Like where how many concurrent users are using the system still doesn't degrade and stuff. It all depends on each application, what their functional needs are, right? Sometimes you can get away with like not having just 100 concurrent users, it's fine. Python thing will just scale. Although like when I said Python or JavaScript, even though like the language itself doesn't give capabilities to support like high concurrent users, you can still offset it by having more servers, more nodes, right? From an infrastructure standpoint, you can negate and offset those issues whereby the load is distributed and stuff. But if you're looking to build something highly performant, lightweight memory footprint, yet not eat up too much cost on your infrastructure, then you will go try to seek some other ways to do it, right? All things can be built in probably even JavaScript, and then instead of like just 10 servers, you can throw 1,000 node servers and still get away with it. There is a very good article in retail Zalando in Europe. They used to run close to 1,000 farm on the API transaction for the checkout, which was built in Python, I think, back then. And then they refactored and rewrote the whole thing in Golang. And the 1,000 node EC2 instances, they reduced it to just 30 EC2 instances, right? They just rewrote the whole logic in Golang. Some of the things, right, you would do for costs and stuff. But yeah, concurrency generally can be handled as long as your code handles and it's safe with ACID properties. You should be fine with any language and get away adding more servers and stuff like that.
So what's the difference between concurrency and parallelism?
These are two different things, actually. There is a very good article from Rob Pike, who invented Golang. I'll send you the link in a bit. Concurrency, think of it like we are all in a single call, right? Let's say if we are all talking together, that's concurrency, doing a particular thing at the same time, right? A particular task is being executed by more than one users. And the concurrency limit in this call is like 5, maybe. Right? Everybody's on, everybody's like actively participating. Parallelism is taking a particular task, breaking them into chunks, executing them, those chunks executing, doing any kind of processing, and then bringing them together. If I were to say an example, like let's take like I want to eat a banana or whatever, right? Like I break it into multiple parts and like I eat throughout the day, but not necessarily forget the time factor, but I eat it independently, like somehow, but get it done, right? A particular task broken into chunks and still executed independently. And then final results are brought together. That's parallelism. Concurrency is a particular task being executed by multiple threads at the same time, if I will. I don't know if I explained it clearly, but yeah, parallelism and concurrency are two different things. Concurrency is number of times being executed, a task is being done at the same time. That's concurrency.
So maybe we are eating the pieces of banana at the same time, that is concurrency.
Yeah,
right?
Different people, yeah, sort of, right, at the same time. And your system should be able to handle it, right? Which means your inventory should have, basically here, the inventory should have enough bananas for all of us to pick up and eat, right?
Here's
at the same time, get it done, yeah.
Here's a book that one of the friends of mine from LinkedIn kind of like mentioned that might be worth looking into. And this kind of talks a lot about the Go language and then concurrency as well. So I can put a link to that in the
yeah, so Go is built for concurrency. Go handles concurrency well. Even Java, we can write concurrent program using threading, right? Using threading, we can route, but we have to manage all those things, the whole cycle and the variables and what, when like multiple synchronization, we need to do all those things, right? Pause, notify, all those capabilities, we need to enable it. But in Go, like there are something called micro threads. It's called Go routines. It handles, you can basically spin off Go routines like minions. It'll go do your job, and then finally it can come back and you can assimilate. I mean, I know I spent almost more than 15 years in Java and its ecosystem, but I am in love with like Go for sure. A lot of reasons, right? It's very concise. It doesn't let you have any imports in the code, which is not being used at all. So the code is like really, really good end of the day. And you have capabilities to do a lot of things.
I guess because we have a few minutes left, I was just going to ask as well, like, and then we can kind of come back to the Kindle, the book. Basically, I was just going to say, do you have any recommendations for like, good stuff on Go? Like, especially like that kind of goes into details about concurrency, like, are courses that go into details about that?
Actually, rather than going into courses, there is a very good article from Rob Pike, who was part of the co-author for Golang. Google Rob Pike, Parallelism versus Concurrency. He gave a very good speech, maybe in 2016, I think, but it should be available online. Rob Pike's Parallelism versus Concurrency. That is a terrific speech. You should definitely listen rather than going into the books, right? The books are going to dwell into how Go handles concurrency, how you can write concurrent program. But this is a very good article on what Akansha was also asking to give a very...
This is the one, right?
Yeah.
Okay.
So the pros, the advantages of Go over Java, if I get it right from Karthik, it's basically that it has better concurrency support and it has better type checking and all. Is that what was the main selling point? Is it just that it supports better concurrency and it is closer to the, it's a lower level than Java and it's faster? Is that the selling?
Yeah, it is much faster. It is writing code is easier and natural in it. Yeah, let's say just a simple example, right? If we were to build an API from scratch in Java, right? We'll install JDK, then we'll probably choose a framework. Let's say we'll choose Spring Framework or whatever, right? If we choose a framework, we manage the whole thing with our dependency with Maven or Gradle, all those niceties, and then we build a framework. And then if you have to interact with database, we'll choose JPA, ORM, whatever, right? Or just prepared statement. The ecosystem, so far, it's okay, right? It's simple, it's familiar. We know, okay, it provides that framework. In Go, you don't need to. Literally, Go has HTTP server in itself. You can just write it.
Wow.
Right? Something quick enough for prototyping and stuff. And then you can improve it with concurrency for speed. If you want to constantly enable speed access, you can, for latency and stuff, you can constantly improve with like, threading. Threading is generally not allowed in J2E if you deploy it in any server, right? Or even Spring Boot. Generally, it's something as a best practice, they recommend not for us to write threading itself, right? Unless it's being handled mostly in the server-side code, right? Every request thread is being spawned. So these controls you have, but it's just like concise and small and quick enough for us to get things done. There are not multiple for loops, just one for loop.
Okay.
Not confusing it too much.
But it's not a functional.
No, it's not functional at all. No, it's not functional. Go is not a functional.
Yeah, if you need functional programming, basically you need parallel Mapreduce kind of Mapreduce kind of a scenario. Then you are better off sticking with Scala, right? Is that the
Scala? If you're more familiar with Java and ecosystem, or there are multiple FSDs, right? Like some, for example, if you're familiar with Circle CI, right? It's one of the leading CI CD tool, pretty much like our code build pipeline or even Jenkins. They use a different FSD called Closure, which runs on top of JVM, right? Different people have chosen different things. There is most upcoming is FSD is Kotlin. The reason Kotlin is very popular is because Android programming also is being done in Kotlin now, right? That's another FSD. So it depends, right? What you want to do. If you're choosing like large big data platform and you want to use Apache Spark, which is in-memory processing, pretty much like next version of in-memory, then Hadoop, yeah, you would choose Scala. If you are using Apache Flink, which is doing big data processing, again, like at streaming level, yeah, you would probably choose Scala. So it depends on what you're choosing. What is the application? Because you don't want to reinvent this whole thing, right? There is no one thing that fits all. So ecosystem, you look into it. Okay, these are things available. This is my business objective, what I want to get done. So, yeah.
I've worked on Kotlin. I'm a big fan of Kotlin. Like I've written like 100 lines of code can be written in like 4 or 5 lines over there. It's like
exactly same way. Scala is the pretty much same way, kind of. But yeah, Kotlin, I heard it's even more concise, even more better and expressive.
Yeah.
I haven't got a chance to play around with it, but yeah.
Yeah, I've also gotten feedback from my fellow coworkers. The code readability is
very nice.
Yeah, yeah.
Nice.
So
Yeah, you should really choose the languages carefully, because like we tend to gravitate towards using it over and over. And you should not spread your energy across multiple languages because you end up learning nothing. So yeah, it's better to kind of understand what are the trade-offs and what is your interest, and like kind of pick the right one to invest in. Yeah.
I agree. I think that might be kind of like the hardest part, is just figuring out which language you want to, work with. And maybe you won't even know sometimes, like when you're building a project, if that language is actually the right one for the job. Maybe it's too powerful, or maybe it's really underpowered. But I guess this just kind of comes with experience, or maybe talking, right? Like, how do you all, I guess at the end of this call, right? How do you all kind of determine what languages you want to learn? Like, do you just kind of like dabble around for a while and then do you study, or what? Like, how do you keep up to date with so many different languages like Scala, Kotlin, JavaScript, Python, Golang, all this?
Okay, go ahead.
Yeah. For me, it's dictated by the domain I am in. I started with Python, and client and server-side execution. For the server-side execution, we use a lot of Java. So in the last 2 years, I've been using a mix of Python and Java equivalently. And now we are going into scalability and trying to see how we can scale. So I'm slowly learning functional programming, and yeah, that's where I go. I just go with how the project goes and where what my skills are and where am I lacking, and then you pick up languages to bridge that gap. Machine learning is a new field, so it's kind of evolving. So yeah, that's where I see myself learning new things.
So it's mainly coming from work then, right? Your work.
It's mainly coming from work and how we build a platform. Yeah.
Interesting. Okay. Anyone else?
I don't have a great story.
Amolia was going to say something. Go ahead, Amolia.
I don't have a great story. It's basically what
I mean, my story is one of the worst story, right? You guys should even look into, because I don't do one thing always. So I'm more customer facing. So I go implement and help them off late, just move from monolithic to microservices, what kind of architecture they have to do, how to do it. And then probably work on the code, help them get there, right? At least for maybe 6 months, I'll help them move there and set the roadmap direction and stuff. So invariably, every customer that I go to, I might not be always in the development team. Like, for example, some are product development team, I'll help them. Some are more infrastructure team where they're trying to scale infrastructure as a code pipeline. So they are more familiar with Python. Of late, like I'm seeing most of the system engineering infrastructure is into Golang. So I have to touch different languages invariably, get to understand, play around for each customer. So that's my job. But more than that, like I'm always curious about different languages, playing around, cut myself thin. That's why I'm not deep into any language. I mean, I know Java well enough for 15 years, so I can survive by Java, Scala, and all, Golang. Yeah, I'm not great in Node.js and stuff. I'm okay. I can get by. Live or die situation, I can do stuff, but I'm not like super awesome in JavaScript.
So do you think that because you have your Java experience, right, do you think that it made it like much easier to pick up the other ones because you know all the...
I think personally, this is my take. This is how I approach, and you guys can call me a spade. If you know one language, for me, every language is pretty much same. Just the principles are a little different. For loop, everything the same. It's pretty much same concept. The syntax might be different. Conceptually, what it does underneath is different. So only thing you need to look into is how they run underneath, runtime, understand the base concepts, but pretty much it should be same, right? Because it's all, so let's say if we categorize all object-oriented programming together, okay, you can extend a particular object, you can implement things, polymorphism and stuff like that in Java. Pretty much Scala has similar features. Scala has little more than Java, right? Some areas, which is great for immutability and stuff like that. So yeah, from my perspective, I don't think anything is way too energy, like how Amelia said, too much energy. Learning a language should be easy for us. Like I think any language can be learned in 21 days. If every day we spend 1 or 2 hours, at least at a base level. And then you can improvise it.
Yeah.
All right. In general, I think functional, if you are a Java developer, right, you basically you have to wrap your head around the functional way of.
Yeah. Functional programming is a little bit different because you have to unlearn what you have learned in OOPS.
Right. Yeah. So
right? It's a very different. That alone, yeah, I understand totally. It's totally different. Sometimes you have to unlearn a lot of things that you have learned in the whole object-oriented programming that we are all taught to think all the time there. You have to think a little different there. I agree. Yeah.
Yeah. So actually knowing Java makes it harder to learn the cool languages.
Yeah, that's why I said you need to unlearn a few things.
Yeah.
All right. I think we can continue this discussion like again, like on Discord and then WhatsApp, and we can also bring it in later on to like again for other sessions. It is 8:40, so we just want to be cognizant of time. So we're almost there. We're almost done with this chapter. There's a little bit more to go. It's a very long one, but I think we're making good progress. And thank you for bringing all the discussions today. This is a great study session, I thought. I'll see you all on Friday.
Yep.
Thank you. Bye.
All right. Bye, everyone. See ya.